Chromatography. The main use in GCSE chemistry is separating mixtures of coloured compounds. This is usually shown in demonstrating the different colours that there are in inks, for example. So what you do is, you take a beaker of water, you take some chromatography paper, you draw a thin pencil line about 1 centimetre from the bottom of the paper, and then you put the blob of the ink that you're going to test on the line that you've drawn. You then allow the water to soak up the paper, and the different colours in the ink will travel different distances up the paper, depending on how soluble they are in the water. So in this example, we've got a dab of very dark ink that looks almost black. And then if we let the water run up, and I show you the time-lapse video, what you see is that the different colours that are in the ink travel different distances, so the water is seeping up according to where the pointer is. And you see at the end that the ink is split into 3 different colours. So the dark green ink contains pink, yellow and blue. This is the finished version. This is the solvent front, so this is how far the water travelled up the paper. And this is the baseline. This is the line on which we put the original dark green blob of ink. One of the things that we can measure from a chromatography experiment is what's called the retardation factor, RF. And the RF we calculate for every single spot is the distance that the spot travelled divided by the distance that the solvent moved. So if we look at our experiment, the solvent, i.e. the water, travelled 5.4 centimetres. And then we can work out how far each of one of these colours moved. Because they're long and they're streaky, the rule is that you go to the middle of the spot. So the pink spot travelled 1 centimetre from the baseline to the middle of the spot. The yellow spot travelled 3.5 centimetres from the baseline to the middle of the spot. And the blue spot travelled 4.8 centimetres from the baseline to the middle of the spot. So if we put the numbers in, the RF of the blue spot is 4.8 divided by 5.4. The RF of the yellow spot is the distance the yellow spot travelled, which is 3.5 divided by 5.4. And the RF of the pink spot is 1.0 divided by 5.4. When you put these into a calculator, you get the RF of the blue spot is 0.89, the RF of the yellow spot is 0.665, and the RF of the pink spot is 0.19. This shows that in the green, dark green, nearly black ink that we had, there are 3 different colours. And because the blue spot has travelled furthest, the blue colour is the most soluble of the 3 in the water, and the pink colour is the least soluble in the water.